On May 10th, 2024, the skies above Mexico glowed green with auroras, a spectacle so rare, people called it magical. But what most didn't know was that the same storm came within hours of knocking satellites out of orbit and silencing GPS across continents. It was a reminder that our sun, the giver of life, is also a ticking cosmic bomb. And now, for the first time in history, NASA believes it has built an AI that can predict these storms before they strike. The sun rises each morning with the calmness of eternity. Its golden rays spill across mountains and oceans, carrying warmth, rhythm, and the illusion of permanence. For millennia, it has been worshipped as a god, charted as a clock, and praised as the giver of life. Yet beneath this serene mask lies a truth far less gentle. The sun is not only a guardian, but a tempest waiting to break. Its surface, a restless sea of plasma, hides magnetic fields twisted into invisible knots. Most days, their release is subtle, scattering whispers of light across the poles in the form of auroras. But on rare occasions, these knots snap with unimaginable force, releasing storms that race across space at millions of kilometers per hour. When such storms strike Earth, they do not arrive as fire, but as electricity, surging into the fragile web of wires and satellites upon which modern civilization depends. History remembers the warnings. In 1859, telegraph systems sparked into flame during what is now called the Carrington Event. In 1989, a storm plunged Quebec into darkness in less than 2 minutes. In 2012, a massive eruption missed Earth by mere days, an invisible near catastrophe that could have ended the digital age before it began. The sun does not choose its moments. It does not threaten with intention. It simply burns, and in its burning lies the power to give life or to erase the illusions of safety. Humanity lives in the fragile balance between those two truths, and the question that remains is simple. When the next storm comes, will we be ready? Discovery often begins with the simple act of looking up. For most of history, the sun was untouchable, a disk too bright to study, too dangerous to stare at. It was a god to the ancients, a clock to farmers, a compass to sailors. Yet the storms that brewed within it remained invisible, their violence hidden behind a blinding veil of light. The first real crack in that veil came in the 17th century. Galileo Galilei, turning his crude telescope toward the sun, saw dark blemishes scattered across its surface. They were sunspots, vast regions of magnetic turmoil, larger than the Earth itself, shifting and multiplying across the star's face. To Galileo, they were proof that the heavens were not perfect, but restless. To modern science, they were the first hints of the storms that lay beyond sight. For centuries, the connection between these blemishes and the Earth below remained mysterious. Yet observers began to notice a rhythm. When sunspots were many, strange lights filled the skies far from the poles. Auroras glowed in latitudes where they had no business appearing, haunting the nights of Europe and Asia. It was as if the Earth's atmosphere itself trembled under an unseen hand. By the 19th century, instruments confirmed what the eye could only guess. Magnetometers, designed to measure the Earth's magnetic field, twitched in synchrony with eruptions on the sun. Invisible lines of force stretched from star to planet, binding them together in a relationship of cause and effect. It was a revelation that shattered the illusion of separation. The sun was not distant. It was reaching out, touching the Earth with storms no wall or border could resist. The truth revealed itself violently in September 1859. Richard Carrington, an English astronomer, observed a sudden flash on the sun, an intense burst of light that erupted without warning. 17 hours later, Earth shook with the storm it unleashed. Telegraph systems sparked and caught fire. Operators felt shocks run through their hands, and lines of communication across continents fell silent in a blaze of electricity. Auroras lit up the skies as far south as the Caribbean, turning midnight into morning. Civilization had just glimpsed the power of its parent star, and the memory would not be forgotten. Yet the lesson was not easily absorbed. Decades passed, and though scientists cataloged sunspot cycles and solar flares, prediction remained elusive. The sun operated in rhythms too vast and chaotic for the human mind to untangle. Astronomers mapped the 11-year solar cycle, noting how activity rose and fell, but they could not say when or where the next great storm would erupt. The 20th century brought new eyes to the sky. Radio telescopes revealed hisses and bursts from the sun, signals of activity invisible to ordinary sight. Observatories mapped coronal loops, arcs of plasma held aloft by magnetic fields, glowing in ultraviolet light. Satellites launched into orbit captured the first direct images of solar eruptions, showing storms not as sudden flashes, but as massive rivers of plasma, billions of tons of matter hurled into space. The discovery was both awe-inspiring and terrifying. The sun was not just radiant, it was restless, boiling with energies that dwarfed the scale of human invention. The most shocking discovery came not from looking outward, but from experiencing impact. In March 1989, a geomagnetic storm collapsed the entire power grid of Quebec within 90 seconds. Millions of people were plunged into darkness on a winter night, not by war or sabotage, but by the distant anger of a star. Satellites malfunctioned, communications faltered, and across the world, systems strained under invisible pressure. The discovery was not abstract, it was lived. It was survival tested against a storm that did not care for human need. Then came the revelation of July 2012. NASA's Solar Dynamics Observatory recorded a coronal mass ejection so massive it rivaled the Carrington Event itself. Earth missed its path by days. Scientists later admitted that if the storm had struck, modern civilization might have been thrown into chaos. Satellites could have been lost, GPS silenced, power grids shattered. Recovery would have taken decades, not weeks. The near miss was a silent warning, a catastrophe that almost happened, a reminder that chance, not preparation, had saved us. It was in this atmosphere of discovery and vulnerability that humanity turned to a new kind of tool. The 21st century brought with it artificial intelligence, systems capable of recognizing patterns too complex for human eyes. NASA's Heliophysics division, in partnership with IBM researchers, began training a model on decades of solar observations. They named it Surya, after the ancient Sanskrit word for the sun. Where telescopes and magnetometers recorded, Surya would interpret. Where human eyes saw chaos, Surya would seek order. The discovery phase was no longer about merely cataloging events. It was about listening differently. Surya absorbed terabytes of data, sunspot records, coronal images, solar wind streams, magnetic field maps. It began to trace connections across time, asking silent questions through its algorithms. When flares erupted, what patterns had whispered before them? When CMEs tore free, what invisible signs had foreshadowed them? At first, its predictions were tentative, yet gradually confidence grew. Surya began identifying precursor signals invisible to humans. Faint shifts in coronal brightness, subtle distortions in solar wind velocity, tiny magnetic tremors in the photosphere. None were dramatic enough for an astronomer to notice. But for Surya, trained on oceans of history, they were the fingerprints of storms waiting to be born. Discovery, then, was not just about the sun. It was about the tools humanity built to hear it. For centuries, the star had spoken in a language too vast, too subtle, too furious for us to comprehend. With Surya, the first syllables of that language began to take shape. Humanity was no longer blind to the moods of its star. For the first time, it had the chance not only to endure storms, but to anticipate them. The more Surya learned, the more unsettling the discoveries became. Scientists had long believed that solar storms followed patterns tied to the solar cycle, rising and falling every 11 years. Yet Surya revealed complexities hidden within those rhythms. Some eruptions appeared in cycles of days, others in subtle oscillations that no human had charted. The sun, it seemed, was not bound by a single rhythm, but by many, layered like overlapping tides. This discovery forced scientists to reconsider what they thought they knew. Space weather had been treated as a curiosity, a rare event to be endured. Now it appeared as an ongoing dialogue, a system that spoke constantly, if only one had ears to hear. Surya's results suggested that every flare, every ripple of solar wind, every shift in magnetism was part of a greater pattern, a language still undeciphered but undeniably present. The implications stretched far beyond astronomy. Power grid operators began consulting space weather forecasts with greater urgency. Airlines reconsidered polar flight routes, aware that radiation exposure could spike during storms. Satellites were tested against radiation more often, their designs modified to endure surges. Each new discovery rippled outward, from laboratories into boardrooms, from observatories into the fragile weave of daily life. But perhaps the greatest discovery was psychological. Humanity realized that its place beneath the sun was not passive. For centuries, storms had struck without warning, leaving societies to endure their aftermath. Now, with Surya and its growing accuracy, there was the possibility of choice. Days of warning meant time to shut down transformers, to reroute flights, to safeguard satellites. What had once been fate could become decision. And in that shift lay a profound transformation. Civilization might no longer be a victim of storms, but a participant in its own survival. Yet with discovery came humility. Surya was not perfect. It sometimes predicted storms that never came, or missed eruptions that unfolded too suddenly to be anticipated. Critics warned that an over-reliance on algorithms could create a false sense of security. Discovery, they argued, was not certainty, but probability, and probability meant risk. Each prediction carried with it a margin of doubt, a reminder that the sun would never be fully tamed. Still, discovery pressed forward. The Parker Solar Probe plunged deeper into the corona, gathering plasma and field data that enriched Surya's learning. Solar Orbiter tilted its orbit to capture images of the sun's poles, regions thought to drive the solar cycle itself. The Daniel K. Inouye Solar Telescope in Hawaii resolved convection cells on the photosphere in unprecedented detail, each the size of a continent, churning like waves in an endless sea. These instruments fed Surya with raw material, and the AI in turn translated them into glimpses of the future. In one trial, Surya identified the subtle signals of a CME nearly 48 hours before telescopes confirmed it. The prediction gave scientists time to issue warnings, satellites to brace, and ground systems to prepare. The storm that arrived was moderate, but its successful forecast was extraordinary. For the first time, foresight had been proven not in theory, but in practice. Humanity had been granted not only knowledge, but time. The discovery phase revealed something deeper still. The sun was not chaos as once believed. Its storms were not random acts of violence. Beneath turbulence lay order, hidden in the subtle dance of magnetic fields and plasma flows. To human eyes, the patterns were invisible. To Surya, they were signatures waiting to be read. This realization reshaped the philosophy of space weather. The sun was not unknowable. It was knowable, but only through tools that expanded perception beyond human limits. Even with this, mysteries remained. Some storms erupted without warning, their precursors too faint or too fast. Others built slowly, only to release in unexpected directions. The discoveries raised new questions. Why did some magnetic knots collapse harmlessly, while others tore open with fury? Why did some storms strike Earth directly, while others veered into space? Each answer uncovered more unknowns. Discovery, it seemed, was not a destination, but a deepening. And so the phase continued, stretching from the 17th century's sunspots to the 21st century's algorithms. Each step built on the last. Galileo's blemishes, Carrington's flare, Quebec's blackout, the near miss of 2012, and now Surya's growing vision. What began as awe had become urgency, and what began as catastrophe had become foresight. The sun's hidden fury was no longer a myth or a distant risk. It was a reality being mapped in real time. The discovery phase ended, not with comfort, but with clarity. Humanity had uncovered truths about its star that were both inspiring and terrifying. The sun was more complex, more violent, and more intimate than anyone had guessed. Yet in that discovery lay hope. The realization that with each storm studied, each data point measured, each pattern recognized, the future became less a mystery and more a story we could prepare to face. The first shock was not a flare in the sky or a headline in the news. It was the realization that everything humanity depends on could unravel in the span of a single day. The sun, so constant in its rising, so dependable in its warmth, was revealed not as a backdrop, but as a force capable of striking civilization at its core. When scientists began modeling the effects of coronal mass ejections on modern society, the numbers felt apocalyptic. A CME of Carrington scale, if directed at Earth today, could cripple power grids across continents, disable satellites, silence GPS, and collapse communication systems. The internet itself, that invisible nervous system binding billions together, could falter in an instant. What had once been seen as distant astronomy was suddenly an existential vulnerability. The history of these shocks begins in 1859. Richard Carrington, sketching sunspots in his observatory, witnessed a sudden burst of light, the first recorded solar flare. Hours later, telegraph lines across Europe and America ignited, shocking operators and setting offices aflame. Auroras painted the skies crimson and green, so bright they woke miners in the Rockies and startled ship crews in the Caribbean. The world had unknowingly passed through a storm that today might have ended the digital age before it began. For decades afterward, the event was treated as a curiosity of history, a strange alignment of technology and nature. But by the late 20th century, the shock returned. On March 13, 1989, a geomagnetic storm struck Earth with force enough to collapse the entire power grid of Quebec within 90 seconds. Millions of people were plunged into cold darkness. Transformers overheated and failed. Across North America, other grids trembled, narrowly escaping the same fate. The storm was not even of Carrington scale. It was smaller, less intense, and yet its damage was undeniable. Civilization had been warned again. Then came 2012. NASA's Solar Dynamics Observatory captured a massive CME erupting from the sun, one of the largest in recorded history. By chance, Earth was not in its path. Had our planet been aligned only days differently in its orbit, the impact could have rivaled or surpassed the Carrington Event. Studies later estimated the economic cost in the trillions, with recovery measured not in months, but in decades. It was a near miss that few even knew had occurred, a catastrophe avoided not by preparation, but by luck. The shock of these revelations rippled through the scientific community. Space weather, once a niche field, suddenly stood at the center of questions about survival. Reports from the National Academy of Sciences warned of long-term blackouts, food supply interruptions, financial collapse. Governments quietly funded monitoring programs, aware that a solar storm did not strike borders or armies, but the fragile mesh of electricity and signals that sustained all nations alike. The sun had become, in this new light, a geopolitical risk as much as a cosmic one. Yet perhaps the greatest shock came not from history, but from the present. Surya, the AI trained to read the sun's moods, revealed scenarios that unsettled even seasoned scientists. Some storms, it suggested, could be anticipated days in advance, giving humanity time to act, but others were merciless, fast-moving CMEs that would allow only hours, perhaps less, between eruption and impact. In such cases, preparation would be frantic, warnings uncertain, and consequences unavoidable. The illusion that technology could always shield us cracked. Sometimes, foresight was simply not enough. The scientific shock was twofold. First, the scale of vulnerability, that entire continents could be silenced by forces invisible to the naked eye. Second, the fragility of certainty, that even with instruments, satellites, and AI, humanity could not guarantee survival, only probability. For a civilization built on control, this was a revelation both humbling and terrifying. To look up at the sun after such discoveries was no longer to see only light. It was to see potential darkness. It was to recognize that the same star that painted dawn across the seas could, without malice, erase the fragile patterns of our daily lives. The sun did not change. What changed was humanity's vision of it, no longer eternal, no longer distant, but immediate, powerful, and dangerous. This realization reshaped not only science, but philosophy. If survival depends on electricity and signals, then survival depends on humility before the forces that can shatter them. The sun is not an enemy, yet it is not benign. It is life and it is risk, warmth and it is fire. To accept this truth is to face the shock of fragility, the recognition that civilization is built not on stone, but on circuits, not on permanence, but on balance. The deeper scientists studied the threat, the clearer the fragility became. Power grids, once symbols of progress, revealed themselves as conduits of vulnerability. Long transmission lines, stretching for hundreds of kilometers, acted like antennas during geomagnetic storms. Instead of resisting the sun's intrusion, they invited it. Currents induced by shifting magnetic fields surged through the lines, overwhelming transformers designed for stability, not for chaos. Unlike smaller components, these massive machines cannot be replaced overnight. Some require months, even years, to build. If hundreds failed at once, vast regions could remain dark long after the storm had passed. Satellites, too, stand as both triumphs and weaknesses. Suspended in orbit, they are exposed directly to solar winds. A geomagnetic storm can flood their electronics with charged particles, scrambling data, erasing navigation, and disabling communication. GPS, the silent backbone of modern life, would falter. Banking systems that depend on its timing signals could desynchronize. Air traffic, reliant on satellite communication, could collapse into confusion. The scientific shock was not only in imagining the darkness of cities, but in realizing that the world's very nervous system, invisible, silent, taken for granted, could vanish in hours. Airlines faced their own revelations. Flights over polar routes, favored for efficiency, pass through regions where Earth's magnetic shield is thinnest. During solar storms, passengers and crew are exposed to heightened radiation. Navigation systems can falter, communications can drop. What had seemed routine was suddenly revealed as fragile. The sky itself was no longer immune. As these vulnerabilities came to light, simulations grew more detailed, more haunting. Scientists ran models of a Carrington-scale storm striking the 21st century. In these scenarios, power grids failed across continents, satellites tumbled into silence, communication collapsed, economies faltered, and supply chains broke. Water treatment plants, hospitals, and transportation systems all depended on the same fragile flows of power. The model showed not a single disaster, but a cascade, one failure amplifying the next, until the global web unraveled. The shock was not only in the possibility, but in the inevitability. The sun had done it before. It would do it again. Surya added another dimension to this shock. Trained on decades of data, the AI began to calculate probabilities. Its forecasts suggested that storms of catastrophic scale were not once-in-a-billion anomalies, but recurring events within the lifespan of civilizations. Some studies placed the chance of a Carrington-level storm in any given decade at around 12%, nearly 1 in 8. To live a century beneath the sun was to gamble against odds that no one could control. Humanity's survival, until now, had been less preparation than luck. And yet, within the shock lay a form of clarity. If vulnerability is undeniable, then so is responsibility. Discovery of fragility forces the choice to prepare or to ignore, to invest in resilience or to trust in fortune. Some governments began to take the warnings seriously, developing protocols for grid shutdowns, satellite safe modes, and airline reroutes. Others delayed, wary of the costs of preparation for an event not yet visible. The shock was not uniform. It was filtered through politics, through economics, through belief. Still, the science spoke with growing force. Each flare observed, each CME tracked, each dataset fed into Surya added weight to the same conclusion. The sun is not passive background. It is an active player in Earth's story, one capable of reshaping it in a single day. This realization changed the very nature of astronomy. Space weather was no longer curiosity. It was survival. For those who worked closest to the data, the emotional weight was heavy. To see the sun erupt in images captured by satellites, to watch magnetic fields twist and break, was to glimpse beauty inseparable from terror. The flares danced like ribbons of light, magnificent, breathtaking, and yet each one carried within it the seed of catastrophe. The shock was not only intellectual, but visceral, awe tinged with dread, reverence braided with fear. What emerged from this chapter of discovery was not panic, but humility. The scientific shock was not a final answer, but an awakening. Humanity had learned that its achievements, grids, Satellites, networks, were fragile by design, stretched thin beneath the light of a star. But it had also learned that foresight was possible, that with instruments and algorithms, survival could be transformed from chance into choice. The sun had not changed. Our awareness of it had. The shock endures because it is unresolved. The next great storm has not yet come. Each sunrise brings not only warmth, but uncertainty. Not only light, but the possibility of darkness. Civilization continues, weaving its fragile circuits beneath the gaze of its star, waiting, listening, bracing. For when the next eruption comes, the question will not be whether the storm arrives. It will be whether we were ready to face it. Discovery is the spark. Investigation is the fire it lights. Once humanity understood that the sun's storms were not distant curiosities, but immediate threats, the work shifted. It was no longer enough to know that storms exist. The question became deeper. Why do they form? How do they grow? And what hidden signs announce their arrival? The pursuit of these answers drew scientists into a labyrinth of magnetism and fire, where each revelation opened more mysteries than it closed. At the heart of this deeper inquiry lies the paradox of the corona. The sun's surface, or photosphere, burns at around 6,000 degrees Celsius. But above it, the corona blazes at millions of degrees. Logic demands the opposite. The farther from the core, the cooler the air. Yet here, heat increases with distance. This coronal heating problem has haunted solar physics for decades. Many suspect that magnetic reconnection, the snapping and rejoining of twisted magnetic field lines, unleashes energy directly into the corona. If so, then the very process that creates ordinary heating may also drive catastrophic storms. The deeper the investigation, the clearer it became that violence was written into the sun's atmosphere. Instruments brought the invisible into focus. The Solar Dynamics Observatory, launched in 2010, recorded the sun in multiple wavelengths, each band of light revealing structures otherwise unseen. Ultraviolet images exposed loops of plasma rising like arches across the surface. Magnetograms traced lines of force, twisting, stretching, waiting for collapse. For the first time, humanity watched the storm's prelude in real time, its choreography written across the corona in light invisible to human eyes. Other tools reached further still. The Solar and Heliospheric Observatory, stationed at the L1 point, blocked the sun's glare to capture the faint halo of its corona. For decades, SOHO has watched CMEs burst outward, calculating their speed, trajectory, and potential to intersect Earth. It was SOHO that confirmed the 2012 near miss, its sensors recording the massive wave that just missed our planet. Without it, humanity might never have known how close it had come to catastrophe. And then came Parker, the solar probe that dared to touch the sun. Launched in 2018, it dives repeatedly into the corona, skimming closer with each orbit. Its shield endures temperatures that would melt most metals, allowing instruments to taste plasma where it is born. What it finds is turbulence more violent than imagined. Switchbacks in the solar wind, reversals in magnetic flow, shock waves racing outward at astonishing speed. Instead of clarity, Parker revealed strangeness. The sun's breath was not steady, but chaotic, a storm within a storm. The investigation deepened not into simplicity, but into complexity. The European Space Agency's Solar Orbiter added a new perspective, tilting its path to capture the sun's poles. No human eye had ever seen them. Here, magnetic fields rise and sink, guiding the rhythms of the solar cycle. To understand storms, one must understand these poles, for they are the anchor points of the star's great magnetic heartbeat. With solar orbiter's images, humanity gained its first glimpse of the sun's crown, and with it, more riddles waiting to be solved. Ground-based tools played their role as well. The Daniel K. Inouye Solar Telescope, perched on Halakala in Hawaii, captured the sun in detail so sharp it revealed plasma cells the size of continents. Its images showed the surface not as smooth, but as an ocean of boiling patterns, each granule a tide of energy surging upward and falling back. Watching them was to witness a scale of turbulence that dwarfed imagination. Each cell might last minutes, yet together, they shaped the forces that could one day fuel storms vast enough to engulf Earth. With these tools, investigation gained depth, yet depth did not mean certainty. Some eruptions grew slowly, like pressure building behind a dam. Others exploded with little warning, releasing plasma within minutes of their birth. The challenge was not only to observe, but to interpret. And interpretation, increasingly, fell to Surya. Fed by torrents of data, the AI began to stitch connections invisible to the human eye. Slight changes in coronal brightness, faint tremors in magnetograms, shifts in solar wind density, all became signals when seen together. Where humans saw noise, Surya saw possibility. Its forecasts suggested that storms were not isolated events, but part of larger rhythms, subtle harmonies within chaos. The more it learned, the clearer it became that the sun's language was written in complexity beyond human cognition. The partnership between human and machine deepened. Scientists tested Surya relentlessly, measuring its predictions against reality. False alarms revealed blind spots, missed storms exposed apps. Each failure was not an ending, but a refinement, sharpening the model with new understanding. Slowly, confidence grew. Surya could not see the future perfectly, but it could glimpse what humans could not. And in that glimpse lay time, precious hours or days in which preparation might mean the difference between resilience and ruin. The deeper investigation went, the more the sun resembled a paradox. It was at once predictable and unpredictable, rhythmic and chaotic, gentle and violent. Its storms were not accidents, but inevitabilities, shaped by forces that could be measured, but not yet mastered. For humanity, the challenge was not to control, but to listen, to learn, and to prepare. As the investigation deepened, one truth grew sharper. The sun's storms were not accidents of chaos, but expressions of hidden order. The challenge was not only to see, but to hear the music beneath the noise. Surya, armed with data, became an instrument tuned to that silent song. In simulations, the AI began to detect patterns that startled even its creators. Before some flares, coronal loops dimmed in ways imperceptible to human eyes. In magnetograms, subtle distortions appeared hours before eruptions. Solar wind velocity fluctuated in sequences that looked random until Surya mapped them as precursors. Each signal alone was meaningless. Together, they formed fingerprints of storms waiting to be born. It was not certainty, but probability sharpened into foresight. Yet investigation also revealed the limits of foresight. Fast-moving CMEs, the most dangerous of all, often erupted without clear warnings. By the time instruments registered them, they were already racing outward at millions of kilometers per hour. Even Surya struggled with these storms, offering at best a handful of hours. The discovery was humbling. Foresight could lengthen the margin, but it could not erase risk. Scientists responded by expanding the scope of investigation. Earth itself became part of the study. Networks of magnetometers across continents mapped the way geomagnetically induced currents flowed through the ground. Geologists found that some regions were more vulnerable than others. In areas with conductive bedrock, currents surged easily, threatening grids with overload. In others, the ground resisted, offering natural protection. The shock of discovery was that vulnerability was uneven, not only between nations, but within them. Some cities could weather a storm, others might fall in silence. Investigators also turned to the oceans. Submarine cables, carrying the pulses of the internet across continents, became subjects of study. Though designed for pressure and salt water, they were not immune to induced currents. Some models suggested that under a severe storm, sections could fail, cutting continents off from one another. The global nervous system, invisible and vital, might fracture in places no one had prepared for. Deeper investigation blurred the line between astronomy and survival planning. Satellites were re-engineered with hardened circuits. Airlines rehearsed rerouting polar flights during storms. Grid operators tested scenarios in which sections could be isolated to prevent cascading blackouts. Investigation was no longer confined to observatories. It spread into the infrastructure of civilization itself. Still, questions multiplied. Why do some magnetic knots unravel harmlessly while others unleash fury? Why do some CMEs veer into space while others strike Earth directly? Why do auroras sometimes ripple gently and other times blaze across skies with furious intensity? Each investigation answered one question, only to reveal three more. In this sense, the deeper inquiry became philosophical as well as scientific. The sun, once imagined as constant, revealed itself as a paradox, giver of life and bringer of disruption, steady in its cycles, yet unpredictable in its moods. Humanity's relationship with it was not one of conquest, but of negotiation. The storms would never cease. The only choice was how well we learned to read them. Surya's role, too, inspired reflection. It was not just a tool, but a partner. Its predictions did not replace human judgment. They expanded it. It was less a prophet than a mirror, showing us what our own senses could not. For some, this raised unease. To depend on a machine was to admit limitation. For others, it was liberation, proof that humility could yield survival. As the chapter of deeper investigation unfolded, a pattern emerged. Humanity's strength lay not in mastery, but in vigilance. The sun could not be controlled, but it could be studied. Its storms could not be stopped, but their approach could be anticipated. Each telescope, each probe, each algorithm was a thread in a tapestry of resilience, woven not to banish fear, but to live alongside it. The investigation continues, restless as the star itself. Each dawn brings not only light, but new data, new mysteries, new questions. And in that endless pursuit lies the fragile hope that when the next great storm rises, humanity will meet it not as a blind witness, but as a listener who has finally begun to understand the language of its star. Discovery is often celebrated as progress, but what followed was not reassurance. It was an escalation. Each answer uncovered deeper uncertainty. Each revelation revealed greater fragility. The more scientists probed the sun, the larger the risks appeared. Knowledge did not calm the fear, it sharpened it. Escalation began with the cycles of the sun itself. Astronomers had long tracked the 11-year rise and fall of sunspots. Yet as instruments improved, patterns emerged that were anything but simple. Some cycles were quiet, producing few storms. Others roared with violence, their peaks bringing storms that shook the magnetosphere to its core. The unpredictability of these peaks unsettled researchers. If the current cycle grew stronger than expected, humanity could be living beneath skies primed for disaster without realizing it. Auroras, once beautiful curiosities, became ominous signs. Reports came from regions far from the poles, skies over France glowing green, lights dancing in Japan, crimson curtains sweeping across the American Midwest. These displays, enchanting to the public, were warnings to scientists. They were proof that the storms were reaching deeper, that the Earth's shield was trembling under pressures greater than expected. Beauty was a mask for escalation. The Parker Solar Probe deepened the mystery. Diving through the corona, it found solar winds behaving like restless waves, reversing, twisting, carrying turbulence that defied prediction. The simplicity of earlier models, which imagined the solar wind as a steady outflow, collapsed in the face of data. Instead of order, there was chaos. Instead of clarity, strangeness. If the winds themselves were so volatile, how could storms be reliably forecast? Surya added its own unsettling discoveries. As the AI trained on more data, its forecasts grew bolder. It began to highlight signals that no one else could see. Faint shifts in brightness, subtle harmonics in plasma oscillations, micro-tremors in magnetograms. To human scientists, these patterns seemed inexplicable. Yet when Surya declared that a storm was coming, it was often correct. The uncanny accuracy sparked both awe and unease. What exactly was the AI seeing? Could it be trusted if its reasoning could not be explained? This was escalation in a new form, not just of storms, but of reliance. To depend on Surya was to admit that human eyes were insufficient, that survival now hinged on a machine's intuition. Some hailed it as progress. Others saw it as dependence of a new and dangerous kind. Mystery deepened with every attempt at explanation. Some storms, massive in size, passed Earth with little effect. Others, modest by appearance, disrupted satellites and power lines. Why? Theories multiplied. Orientation of magnetic fields, velocity of plasma, hidden interactions in Earth's magnetosphere. Each factor added complexity, but none offered certainty. Prediction became less a science of answers than a science of probabilities. Civilization itself magnified the escalation. Governments began to treat space weather not as an academic concern, but as a national security risk. Defense departments quietly studied how blackouts might cripple military readiness. Economists calculated how long markets could endure without satellites. In boardrooms, insurance companies debated whether storms could bankrupt entire sectors. The shock of discovery had matured into the dread of escalation. And yet, mystery refused to yield. For every confident forecast, there were storms that slipped through unnoticed. For every explanation, anomalies lingered. The sun remained a paradox, rhythmic yet unpredictable, familiar yet unknowable. The closer humanity studied it, the less certain it seemed. This is the nature of escalation, to learn enough to recognize the scale of danger, but not enough to control it. To gaze at the sun is to see not only the light of life, but the shadow of fragility stretching across civilization. With each new tool, each new probe, each new algorithm, the storm's mystery deepens and the stakes grow higher. The mystery of escalation is not only scientific, but human. It is one thing to model storms, to trace their magnetic signatures, to calculate their probabilities. It is another to face the question, what will we do when the warning comes? Scientists warned that a Carrington-scale storm could strike without mercy. Surya suggested probabilities, sometimes days in advance, but those predictions carried doubt. Would governments act on a warning that might be wrong? Would cities agree to shut down grids, ground flights, halt stock markets, all on the voice of an algorithm? Escalation was not just the storm itself. It was the tension between foresight and action, between science and politics. In testing scenarios, the results were sobering. Some leaders hesitated, fearing false alarms and economic costs. Others argued that preparation itself would trigger panic worse than the storm. Escalation here was revealed as psychological, humanity's reluctance to treat invisible threats with the urgency they deserve. The storm's power lay not only in plasma and magnetism, but in disbelief. Surya's uncanny predictions only deepened this paradox. At times, it identified signals no one else could explain, forecasting storms before telescopes confirmed them. When those predictions proved true, it felt miraculous. But when they failed, doubt spread quickly. Was the AI seeing real patterns or hallucinating order in chaos? The black box nature of its reasoning magnified unease. Escalation was not simply technological risk, it was trust itself, stretched thin. Meanwhile, the sun grew restless. The solar cycle neared its peak, sunspots multiplying across its surface. Each was a potential storm, a knot of magnetism waiting to snap. Scientists watched as the frequency of flares increased. Auroras appeared at lower latitudes, and magnetic activity intensified. Escalation was no longer theoretical. It was visible in the sky. The mystery deepened as instruments revealed contradictions. Some coronal mass ejections, vast enough to engulf Earth, drifted harmlessly into space. Others, smaller in scale, struck directly with devastating effects. Why? Theories pointed to magnetic polarity, the orientation of fields within the storm. If aligned against Earth's own field, they could slip inside, unleashing chaos. If aligned differently, they glanced off, like waves against stone. But predicting polarity in advance proved elusive. Here, even the most advanced tools faltered. The storm's true shape revealed itself only in the moment of impact. In this uncertainty, humanity's vulnerability became stark. Civilization was built on systems that demanded precision. GPS for timing, satellites for communication, grids for power, data streams for commerce. Yet the sun operated on turbulence and chaos, on fields that snapped and realigned without warning. The escalation of science was the recognition that our world is stitched together by fragile threads, and those threads tremble in the wind of a star. Some thinkers reframed escalation as an opportunity. A storm, they argued, might act as a teacher. It could expose weaknesses long ignored, forcing societies to build resilience. It could reveal which systems endure and which collapse, shaping a stronger future. Yet others feared the opposite, that such an event would not unite, but divide, that nations might hoard warnings, prioritize their own survival, and leave others in darkness. The mystery was not only in the sun, but in us. The public imagination began to shift. Solar storms appeared in documentaries, novels, and films, sometimes exaggerated, sometimes accurate, but always unsettling. For the first time, ordinary people began to grasp the reality that a force 93 million miles away could silence the world in minutes. Awareness itself was escalating, spreading from observatories into living rooms, turning science into shared fear. Yet amidst the unease, awe persisted. Auroras still painted the skies with beauty that defied dread. To stand beneath them was to feel wonder and terror intertwined. The same particles that could collapse grids also lit the heavens with curtains of light. Escalation, in this sense, was not only a threat, it was a revelation that fragility and beauty are bound together, that danger and wonder spring from the same source. The mystery remains unresolved. The sun's rhythms defy simplicity. Its storms erupt with both pattern and surprise. Surya listens, instruments measure, scientists interpret, but certainty stays just beyond reach. Escalation is the price of progress. The more we learn, the more we see how much remains unknown. Mystery deepens because the sun is not a puzzle to be solved, but a force to be lived with. In this deepening, one truth shines clear. The next great storm will come. Whether tomorrow or decades from now, it will arrive as others have before, indifferent and unstoppable. Escalation is not a matter of possibility, but inevitability. Mystery is not failure, but the reminder that life beneath a star is always fragile. Humanity's task is not to conquer that fragility, but to prepare within it, to build resilience from awareness, and to face the storm not in blindness, but in readiness. Discovery and investigation revealed what storms are. Escalation showed what they can do. But beyond facts and warnings lies another realm, the realm of theories and speculations. Here, science stretches its imagination. Here, possibility becomes as important as proof. For when the sun refuses to yield certainty, speculation becomes the only way to glimpse what might lie ahead. One theory whispers that the sun's 11-year cycle is only the surface of a deeper rhythm. Historians of nature trace isotopes in ice cores and tree rings, finding evidence of storms long before telescopes existed. Carbon-14 levels rise and fall in patterns that suggest grand cycles lasting centuries. Some call them the Gleisberg cycles. Others speak of grand minima and maxima, epochs when the sun grows unusually quiet or unusually furious. If this is true, then the Carrington Event was not a freak accident, but part of a repeating chorus. Another storm of equal or greater power is not a matter of chance, but of inevitability across the long arc of time. Another line of speculation dives into magnetism itself. The sun's surface is a battlefield of tangled fields, lines snapping and reconnecting in endless violence. Some researchers argue that there may be hidden thresholds, tipping points where balance suddenly collapses. A flare, they suggest, may be less like a gradual release and more like an avalanche. For days or weeks, stress builds invisibly, and then, with one final trigger, the storm is unleashed. If such thresholds exist, then prediction may depend not on watching eruptions, but on sensing the invisible tension that precedes them. Surya's algorithms, in this view, may already be glimpsing those tipping points in ways humans cannot. Speculation also reaches Earth itself. Why do some storms devastate while others barely touch us? Part of the answer lies in Earth's shifting magnetic poles. The North Pole is wandering rapidly across the Arctic, moving faster in recent decades than at any time in recorded history. Some wonder whether such drift alters how storms couple with our planet's shield, changing vulnerability in ways barely understood. A Carrington-class storm today may not behave exactly as it did in 1859. Earth itself has changed, and with it, the shape of risk. Then there are the speculations about Surya. The AI has identified precursors invisible to human analysis, faint oscillations, unusual dimming, subtle harmonics in plasma waves. Scientists debate what these signs truly mean. Some suspect they point to deeper solar processes not yet captured in equations. Others fear they may be coincidences, patterns invented by algorithms hungry for order. But there is also a bolder speculation that Surya may be uncovering structures unknown to physics, new rules of stellar behavior waiting to be revealed. If true, the AI is not only a tool of prediction, but a doorway to discovery itself. Not all theories inspire hope. Some darken the horizon further. One model suggests that superstorms, far beyond Carrington in scale, may erupt once every few thousand years. Evidence for such events lies buried in radioactive isotopes found in ancient tree rings, where spikes hint at cosmic bombardments stronger than anything in recorded memory. If such a storm struck today, it might not merely disrupt systems, it could erase them, resetting the technological age entirely. These ideas remain speculative, but they force a question no less urgent for being uncertain. How much risk is humanity willing to live with beneath its star? Speculation spreads beyond physics into philosophy. Some thinkers suggest that storms are not only hazards, but teachers. They remind us of humility, of our dependence on forces larger than ourselves. Others go further, imagining that solar activity may have shaped the very path of civilization. Crop failures, famines, migrations, could some have been nudged by the moods of the sun? Could history itself bear the imprint of storms whose auroras once flared over frightened cities? The evidence is scattered, the links uncertain, but the questions linger like shadows. There are even those who speculate about life itself. Radiation from the sun, delivered in bursts over millennia, may have played a role in evolution, shaping genetics in subtle ways. If so, then storms are not only threats to civilization, but catalysts of change, forces that have guided life's path long before we understood their existence. In this speculation, the sun is not just a giver of life, but a sculptor of it, carving futures with invisible hands of plasma and fire. Theories and speculations may never reach certainty, yet they are not idle. They shape how scientists design instruments, how governments prepare, and how societies imagine the future. For in the absence of certainty, imagination is survival. To speculate is to prepare for possibilities unseen. To ask what if is to take the first step toward readiness. Speculation turns practical when it sketches the tools that might one day stand between calm and catastrophe. Engineers imagine artificial magnetospheres, vast coils or plasma bubbles around spacecraft that could deflect charged particles, giving crews a portable shield on routes to Mars. Planetary architects think in stone and regolith, burying habitats beneath lunar soil or Martian cliffs to let rock shoulder what Earth's magnetic field once did for free. The vision is austere and beautiful. Colonies lit from within, while a silent storm rages outside, life surviving in pockets of deliberate shelter. Closer to home, the most grounded speculations revolve around time. If warning becomes hours, perhaps satellites can slip into safe mode and grids can shed load in planned cascades rather than failures. If the warning becomes days, transformers can be bypassed, flights rerouted, deep-sea cables rebalanced, and hospitals stocked with power and water for extended isolation. Time is not technology, yet it is the one resource that turns fragility into preparation. Every theory that matters finally asks the same question: how much time can foresight buy? There are proposals for a multi-point heliophysics network, a halo of sentinels, not just at L1, but also at L5 and L4, watching eruptions from the sun's flank to reveal the true depth and twist of a CME before it turns toward Earth. Triangulation could expose the hidden orientation of a storm's magnetic field, the subtle polarity that decides whether it will glance off the magnetosphere or slip through it like a key. In that geometry lies the difference between auroras over quiet cities and transformers burning in the dark. Electrical engineers speculate about transformers that fail gracefully, modular cores, rapid swap designs, stockpiles distributed across continents. Grid theorists sketch islanding strategies, automatic segmentation that lets regions detach and ride out the storm on local generation, then rejoin once the sky quiets. Substations become chess pieces. The board is the storm. Even financial systems enter the conversation. Timing sources diversified beyond a single satellite constellation. Fallbacks that return clocks to ground-based standards when the sky misbehaves. Submarine cable researchers test the idea that a network can become its own sensor. If deep-sea cables act as unintentional antennas during geomagnetic agitation, their whispering voltages could feed a real-time map of induced currents across oceans. A vulnerability turns informant. The Earth's wiring becomes a nervous system that feels the solar wind passing through stone and salt. Speculation here is elegant. Use the very threads that storms pluck as the microphone that records the melody. Public safety planners imagine space weather drills shared across borders, airports rehearsing polar diversions, traders practicing manual time checks, utilities switching to storm modes without drama. The model is not panicked, it is choreography. If auroras bloom at unusual latitudes, the dance begins. Quiet, automatic, ordinary. In the best version of this speculation, no one notices because everything still works. Not every path reaches toward technology. Some theories point inward, to culture. Warnings are only as strong as the trust placed in them. Sociologists and risk scholars argue for transparent forecasting, where probabilities and uncertainties are spoken plainly, where the public is treated not as a crowd to be soothed, but as humans capable of understanding odds. In this vision, a solar storm watch is as familiar as a coastal hurricane alert, rare, serious, and comprehensible. There is a harder speculation, too, that resilience may depend on accepting periods of deliberate quiet. A civilization that can throttle non-essential power, pause extraneous traffic, and slip into a low-noise mode for 48 hours is a civilization that survives. The romance of seamless continuity yields to the wisdom of a graceful pause. It is not defeat, it is design. Surya remains the most provocative frontier. Some researchers propose hybrid models, physics where physics is strong, learning where patterns defy equations. In such systems, Maxwell's laws and magnetohydrodynamics frame the stage, while machine attention finds the tells. A dimming here, a twist there, a cadence in the solar wind that hints at acceleration. The speculation is practical. Reduce the black box dread by anchoring inference to mechanisms. Let the machine point. Let physics verify. Let the two argue until warning becomes reliable. Others push farther, suggesting Surya could become explainable by example. Not a theorem, but a gallery. Storms of this signature led to outcomes like these. It is not the elegance of a derivation, but it might be the clarity decision-makers need at 2 a.m. when a line has to be opened, a satellite spun, a grid partially dimmed so it can live to shine tomorrow. Ethicists add a final layer, equity. If foresight exists, who receives it first? If warnings are precise, do markets move before hospitals do? speculation expands into obligation. A storm shows no border, neither should the message that it is coming. Theories here are not equations, but compacts. Agreements that in the hour of the star, the signal moves fastest to those who most need it. There are more adventurous branches. Some imagine terraforming scale shields, in-film structures at L1 that cast a variable shadow, easing the solar load during superheated epochs, or diffusing the brunt of a historic CME. The engineering is staggering, the politics more so. Yet even as a thought experiment, it reframes the relationship to the star. Not conquest, not submission, but modulation. An instrument lightly tuned rather than an enemy fought. A different strand looks backwards to archives of light, observatory plates, ship logs, monastery notes of strange nights that glowed like dawn. In these fragments, theorists hunt for forgotten storms to refine probabilities. The past becomes a dataset, the planet a memory palace. Each recovered aurora, each magnetometer twitch from an age of brass and ink becomes another bead on the thread, stretching toward a forecast measured in decades. Then there is the speculation that touches meaning. Perhaps storms will shape the temperament of civilizations that live farther from Earth, not by apocalypse, but by cadence. Societies under thin skies may grow patient, learning to pause when the sun speaks loudly. Calendars might carry new holy days, days of quiet systems and shared food, of stories told by lantern when signals rest. Culture, like circuitry, may find resilience in rhythm. All speculation curves back to a single image, a quiet planet under a bright disk, instruments watching, algorithms listening, people deciding. Theories can be argued, probabilities can be revised, forecasts can be wrong. What remains is the willingness to attend. The sun will not explain itself, but it leaves traces. In those traces, minds can meet, human and machine, physics and pattern, caution and courage. The final, gentlest speculation is this: that attention itself changes the future, not by bending a star, but by bending response. A world that listens early, moves early. A world that moves early, suffers less. Somewhere above the blue, magnetic fields knot and unbraid, and a river of particles takes aim at space. Somewhere below, a signal arrives. A hand lowers a switch. A pilot takes the longer path through the night. A hospital hums on borrowed power while the sky burns green. The storm passes. The lights are still on. In that possibility lies the worth of every theory. In that ordinary miracle, the unbroken morning after a night that could have gone dark, speculation becomes stewardship, and foresight becomes a quiet form of grace. Civilizations have always built instruments to extend their senses. Where eyes fail, lenses magnify. Where ears cannot hear, receivers translate whispers from the void. To live beneath the sun is to live beneath a presence both nourishing and threatening. And so humanity has forged a vast network of tools to watch its moods. These instruments are not ornaments of curiosity. They are the first line of survival. Orbiting above Earth, the Solar Dynamics Observatory, SDO, has become one of the most tireless sentinels. Since 2010, it has watched the sun in more than 10 wavelengths, its cameras capturing eruptions, sunspots, and magnetic arcs with breathtaking clarity. Each second, it streams torrents of data back to Earth, building an unbroken chronicle of solar behavior. To scroll through its images is to see the sun not as a static disk, but as a living ocean of fire, restless and ever-changing. Farther away, nearly 1,000,000 miles sunward, the Solar and Heliospheric Observatory, SOHO, has kept its vigil since 1995. Positioned at the L1 Lagrange point, where gravity and orbital motion balance, it blocks the sun's glare with a coronagraph, unveiling the delicate halo of the corona. From this perch, SOHO tracks coronal mass ejections as they burst outward, calculating their speeds and plotting their paths. For decades, it has been the eye that first sees when a storm takes aim at Earth. Closer still to danger flies the Parker Solar Probe. Launched in 2018, it skims into the sun's outer atmosphere, braving radiation and heat behind its carbon composite shield. Its instruments taste plasma at the very place solar winds are born. Each dive returns turbulence stranger than models predicted. Switchbacks, sudden reversals, bursts of energy like unseen waves breaking against invisible shores. Parker does not merely observe from afar. It plunges into the furnace itself, a craft that listens where no machine has dared. To the side, the European Solar Orbiter follows a tilted path that carries it above the sun's poles. For the first time, humanity can glimpse the high latitudes where magnetic fields twist and sink, where cycles of activity begin their rise and fall. These images are more than portraits. They are clues to rhythms that govern not only solar storms, but the cadence of centuries. On Earth, instruments stand as mirrors to those in orbit. The Daniel K. Inouye Solar Telescope in Hawaii, the largest of its kind, resolves features as small as 30 kilometers on the sun's surface. Its images reveal convection cells the size of continents, boiling and churning in endless motion. Networks of magnetometers scattered across the globe record subtle tremors in Earth's field, the faint signatures of storms before they strike. Together, these ground-based sentinels form a lattice of vigilance, filling in the spaces where satellites alone would leave blind spots. Yet instruments by themselves are not enough. To know is one thing, to trust what is known is another. This is where ongoing testing begins. Each tool must prove itself against the sun's fury, its forecasts measured against reality, its accuracy judged in the crucible of storms. The process is relentless. Predictions are logged, outcomes compared, failures dissected. Every miss becomes a lesson, every false alarm a refinement. The sun does not grant leniency, and so testing cannot rest. In this chain of vigilance, Surya AI has taken its place as a voice both novel and unsettling. Fed with torrents of data from satellites and telescopes, it learns by pattern, not by law. Where physics-based models rely on equations of plasma and magnetism, Surya listens for whispers hidden in complexity. A dimming in one wavelength, a tremor in another, a shift in the solar wind. Each alone might be dismissed. Together, in Surya's memory, they become the faint handwriting of a storm to come. But this foresight must be proven. Testing Surya means exposing its forecasts to the harsh light of reality. Sometimes it succeeds, catching storms days before human eyes suspect. Sometimes it fails, predicting eruptions that never arrive. Each error is cataloged, not to dismiss the AI, but to refine it. Over time, the balance improves. Its warnings grow sharper, its false alarms fewer. Testing is not punishment, it is the rhythm of growth, the discipline of vigilance. Testing extends beyond laboratories into the infrastructures of civilization. Power grid operators simulate storm scenarios, shutting down lines in drills to see how systems respond. Airlines rehearse rerouting polar flights to lower latitudes, minimizing exposure to radiation. Satellites are commanded into safe modes in practice runs, their systems hardened against imagined waves of charged particles. These rehearsals are not theater. They are blueprints for survival. written in the language of preparation. Yet even in practice, the fragility is evident. Transformers tested against overloads reveal their limits. Satellites show how easily circuits can be disrupted. Cables whisper their vulnerabilities. Testing does not banish fear. It sharpens it into clarity, showing where defenses hold and where they must be rebuilt. What emerges from these ongoing trials is a simple truth. Survival depends on layers. No single instrument, no solitary model, no isolated AI is sufficient. Together they form a shield of foresight, imperfect but better than blindness, fragile but stronger than denial. To test again and again is to admit weakness and to build strength from it. The deeper the tools reach, the more they reveal how fragile the line is between foresight and disaster. Instruments sharpen the picture, but storms remain vast, indifferent. This is why ongoing testing is not an accessory to science, but the very heart of it. Without rehearsal, data is only memory. With rehearsal, it becomes preparation. Around the world, scientists stage drills using historic storms as templates. The Carrington Event is replayed in simulations. Its currents imposed on modern grids. The Quebec blackout of 1989 is scaled upward to a continent, revealing cascading failures across entire regions. The 2012 near miss is reimagined as a direct hit, forcing satellites, cables, and grids into collapse. Each scenario is grim, but each one forces action. Weak points are exposed, protocols rewritten, systems strengthened. Testing transforms catastrophe into instruction. Time remains the most precious variable. If instruments and AI can give only hours, responses are frantic. If they can give days, resilience becomes possible. Testing measures this margin relentlessly. A forecast is meaningless if it cannot be acted upon. Airlines must know precisely how long it takes to divert dozens of flights from polar routes. Grid operators must know how quickly transformers can be disengaged without blacking out entire cities. Satellite operators must calculate how long it takes to command fleets into safe mode. These drills answer questions not with speculation, but with timing measured to the second. The results are sobering. In many cases, margins are thinner than comfort allows. Some systems cannot be paused quickly enough. Some backups are too small, too fragile. Testing reveals not triumph, but inadequacy. And yet, this is its power. To find the breakpoints now is to prevent collapse later. Every vulnerability exposed is one less surprise when the storm comes. Testing is also global by necessity. No nation can watch the sun alone. Networks of satellites and telescopes span continents. Their data shared across agencies. American instruments feed European models. Japanese observatories supply details to Canadian archives. South African magnetometers complement Arctic measurements. A solar storm does not strike one border. It sweeps across the planet's shield. Testing ensures that resilience is shared, that warnings move as quickly as light will allow. Still, inequities remain. Many nations lack access to advanced monitoring or resilient grids. Testing scenarios highlight this divide starkly. A storm that advanced countries endure may devastate others. This realization has transformed space weather from a purely scientific challenge into an ethical one. If foresight exists, who receives it? If warnings are issued, who ensures they reach every community, every village, every fragile system? Testing cannot answer these questions alone, but it forces them into the open. Beyond Earth, speculation turns into trial. Crewed missions rehearse solar storm protocols, astronauts practicing retreat into shielded modules at the first sign of radiation. Spacecraft designs undergo particle bombardment in labs, their circuits tested against storms that may one day sweep across Mars-bound journeys. Investigation shifts from theory into survival training. For those who will travel beyond Earth's magnetic shelter, the storm is not an abstraction, but a constant presence. Testing is the only armor they will have. New instruments are conceived with testing in mind. Plans for constellations of probes at multiple Lagrange points could triangulate eruptions, measuring polarity and direction before Earth is struck. Ground-based radio arrays are tuned to catch faint signatures of flares, mapping the sky in frequencies invisible to human eyes. Even submarine cables are reimagined as sensors, their induced currents becoming silent witnesses to the sun's touch. Each tool, once tested, becomes part of a web of vigilance that stretches from orbit to ocean floor. But the most profound testing is not mechanical, it is cultural. Will societies act when the warnings come? History offers reasons for doubt. Disasters often strike hardest where preparation was possible but ignored. Leaders hesitate, fearing costs, doubting forecasts, and underestimating risks. Testing, therefore, extends beyond instruments into psychology. Governments run communication exercises, rehearsing how to explain probabilities without inciting panic. Public drills simulate blackouts, ensuring that when the lights fail, communities know where to gather, how to endure. The storm may not wait for consensus. Readiness must exist before debate. Surya remains both a promise and a puzzle in this landscape of testing. Each forecast it issued becomes a trial. Each success strengthens trust. Each failure erodes it. Scientists compare its results with physics-based models, measuring convergence and divergence. When both agree, confidence grows. When they diverge, questions multiply. Is Surya seeing something physics cannot yet explain? Or is it mistaking noise for signal? Testing does not silence these questions. It sharpens them. Out of this tension, resilience grows. What emerges from this ceaseless process is not mastery, but readiness. Humanity cannot command the sun. It cannot prevent the snapping of magnetic fields or the eruption of plasma into space. What it can do is listen, measure, test, and prepare. Instruments extend our senses, AI extends our insight, and testing extends our courage to act before catastrophe. The chain is fragile, but it is real. From telescopes on mountains to probes diving into the corona, from magnetometers buried in soil to cables stretched beneath oceans, the Earth has grown ears tuned to its star. Their chorus is imperfect, but it is the difference between blindness and foresight. And with foresight, even in small margins, survival becomes possible. There comes a point in every journey of science when the instruments fall silent. The data pauses, and only reflection remains. Numbers may chart trajectories, forecasts may mark probabilities, but the human spirit asks another question. What does it mean to live beneath such a star? The sun is the oldest companion humanity has ever known. It has risen over every civilization, warmed every harvest, lit every sea. Without it, the Earth would be stone, frozen and barren. It is life itself, condensed into light. And yet, within that same brilliance lies the power to remind us of our fragility. For the sun does not shine with intention. It does not burn for us. It burns because that is its nature. And in its nature lies both our blessing and our peril. Philosophers once saw in the sun a metaphor for truth, too bright to gaze upon directly, yet too vital to deny. To look into its face is to be blinded, yet to turn away is to live in darkness. The paradox still holds. The more we uncover about solar storms, the more the sun becomes both teacher and trial. It tells us that beauty and terror are not opposites, but twins, born from the same fire. Incarnate. Green curtains rippling across the night. Red flames shimmering on the horizon. Violet waves flickering like spirits of the sky. They are the most poetic gift a storm can leave. And yet, they are warnings too. The visible scars of collisions high above, where particles from the sun crash into our shield. The same dance that enchants the eye may be the herald of currents tearing through cables, of satellites falling into silence. Awe and threat share the same sky. The scientific shock of earlier chapters gives way here to humility. Civilization is a marvel of wires and signals, grids and satellites. It feels permanent, yet it is delicate. A storm reminds us that what seems eternal is in truth temporary, stitched together by currents that may vanish in an hour. But to recognize fragility is not despair. It is clarity. It is the knowledge that survival is not control, but adaptation. In this light, Surya AI becomes more than a tool. It is a mirror. It does not master the sun. It teaches us to listen more closely. Its forecasts are not guarantees, but reminders that even intelligence beyond human comprehension remains bound by uncertainty. And perhaps this is fitting. For if the sun cannot be mastered, then the task is not dominance, but humility. To learn, to adapt, to prepare, to live wisely beneath something far greater than ourselves. Some thinkers speculate that storms are not accidents but catalysts, that they may shape history, forcing societies to grow resilient, or even shape the path of life itself through subtle changes across aeons. If so, then every storm carries not only a threat, but meaning. It becomes part of the larger story of survival, written not in books, but in auroras across the sky, in blackouts endured, in warnings heeded or ignored. The storms are pages of a cosmic text we are only beginning to read. And yet, reflection does not stop at fear. To stand beneath the sun is also to stand in awe. Each sunrise is a reminder that despite the risks, the star continues to give. Its light nourishes forests, drives oceans, feeds crocs, and warms skin. To live with fragility is to live with wonder. The recognition that existence itself is a gift, precarious yet beautiful. The storms do not cancel the dawn. They make it more precious. The emotional closeness begins not with answers, but with acceptance. We cannot stop the sun from erupting. We cannot erase its cycles or silence its fire. But we can listen. We can prepare. We can build not with arrogance, but with awareness. Resilience is not denial of danger, but readiness to live within it. In this way, the story of solar storms is the story of humanity itself. Fragile yet enduring. Vulnerable yet resourceful. Small against the scale of a star, yet capable of foresight, of cooperation, of grace. To live beneath the sun is to accept this paradox, to hold in our minds both fear and wonder, and to continue, day by day, in the fragile space between them. The sun does not choose its moments. It does not distinguish between the centuries of hunters who feared its setting, the farmers who prayed for its return, or the digital empires now dependent on its quiet light. It burns, indifferent, eternal by human measure, and in that indifference lies the most humbling truth. We exist not because the universe cares, but because the universe allows. This allowance is fragile. We live in a balance thinner than it seems. Oxygen fills the air, but only because of ancient algae. Crops grow, but only within narrow climates. Signals connect us, but only through grids and satellites that storms can silence. A civilization may imagine itself strong, yet it is no more permanent than the lines of aurora across a winter sky, radiant, fleeting, delicate. Yet fragility is not futility. It's an invitation. To know that we are small is to know that we must act with care. The storms remind us that resilience is not born of arrogance, but of humility, of planning, of attention. Warnings heeded, drills rehearsed, systems hardened. These are acts of reverence as much as of survival. For to prepare is not to defy the sun, but to honor it, to accept its power and live wisely beneath it. In this, Surya stands as a symbol. It does not conquer the sun, but it listens to it. It does not erase mystery, but it translates whispers into warning. Its existence proves that humility can be fertile, that admitting our limits can lead to strength. The partnership between human curiosity and machine attention is not mastery, but stewardship. It is the recognition that foresight itself is a form of grace. There will be storms again. Some will pass quietly, scattering auroras across forgotten skies. Others may shake the very structure of civilization. Perhaps one day a storm will strike with the fury of Carrington, or worse, and humanity will be tested as never before. This truth cannot be escaped, but it can be faced. To know is to prepare, and to prepare is to endure. In the glow of auroras, there is both omen and gift. Green ribbons shimmering across midnight horizons, crimson veils glowing over frozen seas. They are the most beautiful warnings the earth will ever know. They remind us that danger and wonder share the same fire, that what threatens us also astonishes us, that we are never closer to awe than when we face the edge of fear. And so the reflection ends where it began, with the sun itself, the first light to touch the earth, the first warmth to cradle life, the first rhythm to guide time. It is the same star that may one day test us with storms beyond measure. To live beneath it is to live in paradox, fragile yet enduring, threatened yet sustained, humbled yet inspired. The future is unwritten. Storms will come. Some will pass unnoticed, others will shake the world. Between them, there will be days of calm, mornings filled with ordinary sunlight, evenings of golden skies. These are not guaranteed. They are gifts. To receive them with awareness, to prepare for the nights when the sky itself turns against us. That is the task of a civilization wise enough to endure. And perhaps that is the final grace of the sun, not only that it gives light, but that it reminds us of our place. We are small yet capable, fragile yet resilient, temporary yet luminous in our striving. The storms may come, but so too will dawn. And in that dawn lies the quiet promise that even beneath fire, life can continue, if it remembers to listen, to prepare, and to endure.